Hello everyone, my name is Edvero Jacob. My matrix number is B20BE0001. So this video is for my lab assignment 2. So first of all, I would like to introduce you what is digital photogrammetry. So digital photogrammetry is the science of obtaining high precision measurements from photographs and other forms of imagery. Digital photogrammetry is revolutionizing the way we think about and work with maps. So photogrammetry has been used for a variety of applications such as engineering design, natural resource and environmental inventory, hydrographic surveys, and archaeological mapping. So this is our software that we've been used to process our drone data, which is Pix4D Mapper. So basically, Pix4D Mapper is the leading photogrammetry software that transforms images into accurate and georeferenced digital models. Automatically convert images taken by drone, by hand or by plane into highly precise 2D maps and 3D models. These outputs are customizable, timely, and complement a wide range of application and software across industry. Next, Phantom 4 drone. So this is a little bit specification for this drone. Phantom 4 drone, a 1-inch sensor with variable aperture with a 4.3 mile range and obstacle avoidance that could also shoot 4K video at 60 frames per second. This adds the ability to get some depth of field to your image and video, giving it more cinematic look and look less like a GoPro strapped to a gimbal on a drone. So in this project, we are using Phantom 4 drone. So this is a setting that we need to do before we fly our drone. So the first is flying height, 65 meter from takeoff level. End lap is 75%, side lap 70%. Spatial resolution is 40 centimeter, number of photos 70, angle of camera 0 and 25 degrees from nadir. So next, this is the method how we process the images from the drone. So the software that we have been using is Pix4D Mapper. So the first thing first, we need to go to the new project and then we name our project. And then we click next, and then we need to add all the images that have been taken from the drone to this software. And then we click next. For the image properties, we just give it as default, and then we click next. And then for this output coordinate system, I'm using WGS84, and then click next. And for the processing option, I will use 3D maps, and then click next. So next, we go to the project and choose GCP manager, and then we import the GCP, the point that's already have coordinate. This is to make sure that the maps are based on a true location. So before we start, we need to go to the processing option. So in this processing option, we need to tick the output that we want to. So the first is the initial processing. We just keep it as a default for these options. Second, for the point cloud and mesh. For the point cloud, we change the image scale to the original image size, and then we need to export to the LAS format. Next, in the 3D texture mesh, we're setting it to high resolution and export to DXF and save in 3D PDF. So third, the DSM and automosaic and index. So in the DSM and automosaic, we just keep it as default. So in the additional output, we tick the geotiff, and in the index calculator, we just keep it as a default, and then click OK. After that, we take all the three processing, initial processing, point cloud and mesh, DSM, automosaic, in index, and then we click start. So after we finish all the three processing, so this is the output for this project. So the first output is the orthophoto. So this is the orthophoto from this project. Next, this is the DSM output for this project. And this is the DTM output for this project. So next, this is the output for the 3D mesh for this project. So the conclusion for this project is the ease and speed with which data can be gathered is photogrammetry's main benefit. With the aid of UAV, UAS, or satellite imaging, photogrammetry can assist in taking pictures, analyzing the data to obtain measurements, and quickly and cheaply turning them into 3D maps. That's all from me. Thank you very much.